Good morning, everyone.
Good morning, ma'am.
Good morning.
Good morning, ma'am. Good
Very
morning,
happy
Good
ma'am.
to
morning, ma'am.
all of you.
Good morning, ma'am.
Good morning. Yes, first internal syllabus includes Module 1 and Module 2. Module 1 DC circuit, Module 2 AC circuit. Okay, today I'm going to start a new chapter that is Module 3 Transformer Basics. Have you seen the syllabus? Have you seen the syllabus of transformer?
Yes, ma'am.
Okay, so please wait. Let me share my screen first. Is the screen visible to all of you?
Yes, ma'am.
Okay. So let us start with transformer. Transformer is one basic type of electrical machines, which is a static device widely used uh, across the country for many types of applications, starting from power transmission line to simple DC power supply unit. So in this slide, a single line diagram has been drawn showing that how power is getting transmitted from power generating station to consumer end, right? So mainly 11 kilovolt is the type of typical voltage level at the generating station, which is getting stepped up by using a step up power transformer up to 400 kV, and that power with 400 kV is getting transmitted over the long transmission line more than 100 kilometers, and it is further sent to a substation. This is a substation block contains step down power transformer, which is actually used to step down the high voltage uh, like 400 kV uh, to 33 kV, 33 kilovolt, which can be easily supplied to the consumer end. Can be a industry, consumer can be an industry, or it can be any other type of applications. So all these are power transformers. Okay. So one of the main reason why we chose AC, alternating voltages and alternating currents in our homes and other workplaces, where AC supplies can be easily generated at the convenient voltage level, and further that voltage can be transferred or transformed, hence the name comes transformer, into much higher voltages and then distributed around the country over very long distances using suitable cables. Right? Now, the reason for transforming the voltage to a much higher level is that higher distribution voltages implies very low amount of current, keeping the same power rating, right? Because in case of transformer working principles, in case of transformer working, there will be no change of power either at the primary side or at the secondary side. I'm coming to this primary and secondary windings of transformer later on. But for the time being, you just understand that it contains two windings. One is called primary and another one is called secondary. And whatever be the voltage supplied to the primary side will generate the supplied current. But the amount of power, which is just the product of voltage and current, will remain same at the secondary side. Okay, so there is no change of power level. Only the voltage or current can be changed. It can be either stepped up or it can be either stepped down. Now, since the transformer is working with very higher distribution voltages, as we have seen the single line diagram, almost 400 kV. So it implies that the current is very low, keeping the same power. Therefore, losses are less because loss means mainly the copper losses, which are basically the I square R losses along the network grid of cables. So if current is less, definitely square of current will be less, and hence the losses will be reduced. So this is the main reason why we are using transformer and why we are using AC transmission over the long transmission lines to distribute the power, electric power from the generating station to the receiving station or to the consumer station. Now these higher AC transmission voltages and currents can then be reduced to a much lower, safer and usable voltage level where it can be used to supply different electrical equipments in our homes and workplaces, which are mainly operated on very low voltages, not very high like 400 kV or 33 kV. And all this is possible because of the voltage transformer, right? So a transformer is basically a simple static or stationary device, definitely an electrical device. Why it's called stationary or static device? Because it doesn't contain any rotating parts like other machines, PC machines, uh, synchronous machines, where rotating parts are available along with the stationary parts. But in transformer, there is no rotating parts. It contains only two windings wrapped around a suitable core. Now, this core can be of many types. It can be of air core medium. It can be of ferrite core medium, right? But entire working is uh, done by electromagnetic induction. It is based on Faraday's laws of electromagnetic induction. That means between these two windings there is a magnetic field. So there is no as such electrical connection between these two windings, right? That's why it's called static device or electromagnetic passive electrical device that works on the principle of Faraday's law of electromagnetic induction by converting electrical energy from one stage to another or from one circuit to another. The transformer does this by linking together two or more electrical circuits using a common oscillating magnetic circuit, which is produced by the transformer itself. Right? Look at this basic block diagram of a single phase transformer. So mainly we call it as voltage transformer because its cause or the source is voltage. That's why it's called voltage transformer, because current transformers are also available in the market. So we will categorize this basic transformer as the voltage transformer because here the source of excitation is of AC voltage, alternating source voltage. So look at the basic block diagram. Here This is the primary winding. It is just like a primary coil wrapped the around the core, and this core contains two limbs. These are called limbs. So primary winding will be wrapped around the first limb, and this is the secondary winding wrapped around the second limb, and this is the core. It may be a ferrite core, it may be air core, or it may be any other type of core available in the market. This VP is nothing but the source of excitation, which is definitely an alternating voltage. You can see alternating sinusoidal voltage waveform is drawn here, which is to be seen to the primary side. Because of this alternating voltage, alternating current will be generated at the primary circuit, at the primary coil, which is denoted as IP in this figure. And what is NP? NP is number of turns present in the primary winding. Because depending upon the number of turns available at both sides of the transformer, the, the type of transformers will be decided, whether it is a step up transformer or step down transformers, etc. Now look at the secondary circuit or secondary side. It is also having NS number of turns. The voltage developed across the secondary coil is PS, and the current flowing through the secondary circuit is IS, and this is a bulb which is nothing but a load, right? So if you connect a bulb across the secondary circuit, or if you connect a load across the secondary circuit, then only the secondary current will be flowing through the load. Then only this part will be completed and current can flow. Otherwise, no secondary current will flow if there is no load, if there is no bulb across the secondary side of the transformer. And what is this phi F? This phi is called the magnetic flux, which will be developed by the transformer working action, and it will be confined within the core material of the transformer. And because of this flux phi M, EMF will be induced, the voltage will be induced at the secondary coil because of the Faraday's laws of electromagnetic induction. Now, what is Faraday's law? What is Faraday's law? Whenever an alternating current is passing through a coil, through a winding, a magnetic flux will be created, and this flux will in turn produce a voltage or EMF across the coil, which will oppose the very cause of it, which is nothing but the alternating current. That means EMF produced at the coil is proportional to N d phi dt. Right? What is this N here? NP, because now we are talking about this side of the transformer, which is called the primary side, right? So the primary side EMF or the primary induced EMF will be proportional to N d phi dt. Now, what is this phi? This phi is the flux produced within the core, right? So whenever there is a rate of change of flux, a voltage or EMF will be induced as the primary winding. Now this flux will be confined within this core, and this core contains secondary circuit, secondary coil also. That means this flux will be also linked with this secondary coil, right? But the main cause of production of this flux is the primary current, is IP, the source current, right? And that's why we will call the voltage induced at the secondary circuit as the mutually induced EMF, because this flux is now mutually linked with both the coils. Okay, so because of the mutual inductance, because of this mutual flux linked with both the coils, mutually induced EMF will be developed across the coil, right? And the EMF developed across the secondary coil is because of the flux, the main flux phi N, which is produced also because of the main supply current IP. So indirectly, IP is responsible for the generation of voltage induced at the secondary circuit. Okay, and once there is EMF induced across the secondary coil, and if the secondary side is completed via a load circuit, definitely the secondary current IS will be flowing through the circuit, and because of the secondary current, definitely a voltage will be developed because the load, which is nothing but PS. So in transformer working, definitely the input voltage is AC. DC can also be produced, but uh, transformer is basically AC to AC device, and DC is possibly connect at the input side of the transformer till there is a rate of change of current. If current becomes steady or constant, there will be no rate of change of current, right? So there will be no production of EMFs. Okay, so DC circuit is allowable if there is a rate of change of current. So as soon as you are switching on the DC supply, there is a rate of change of current, but after that, after certain time, when the system reaches the steady state, your system current or system output voltage will become constant. So there will be no voltage induced, so transformer will not work. So mainly we use AC, alternating voltage or alternating current in transformer application. So this is the basic principle of transformer working, right? That means the transformer working is based on the common oscillating magnetic circuit. That means the common magnetic flux phi m, what I have shown just now, which is produced by the transformer itself. A transformer operates on the principle of electromagnetic induction in the form of mutual induction that I have explained just now. So if you have any question regarding this, you can raise your hand. I have explained very basic thing of transformer working, very basic thing of transformer. So if you have any question, you can ask me. Otherwise, I will proceed.
No,
Okay.
Namaste.
So next, moving to the mutual induction, which is the process by which a coil of wire magnetically induces a voltage into another coil located in close proximity to it. That means here in this case, secondary coil is just mutually coupled with the primary coil, because the secondary coil is just placed very near to the primary coil. So in practice also, what we do when we design the transformer, actually around the core, first we wrap the primary winding, and just above of that we wrap the secondary winding around the same core. Okay, so that they can be tightly coupled, they can be tightly bound, right? So depending upon this bondings between the two coils, more output will be obtained. The more EMFs will be generated at the secondary side. Okay, so we can see that transformers work in the magnetic domain, and transformers get their name from the fact that they can transform one voltage or current level into another. And also the transformers are capable of either increasing or decreasing the voltage and current levels that I have said earlier, without modifying its frequency or the amount of electrical power being transformed from one winding to another via the magnetic circuit. That means when the current is getting transferred from one winding, from one electrical circuit to another, where in between the two electrical circuit there is only the magnetic coupling, common magnetic field available, there is no electrical connection between the two windings, as you can see from the diagram, right? So what happens, actually the current can only be transferred, the voltage can only be transferred from primary winding to secondary winding, following a magnetic field, common magnetic field between the two windings. But always remember that there is no change of power level between the two sides of the transformer, and also frequency should remain fixed, right? So whatever the value of frequency here at the primary side, that should not be changed here at the secondary side. So if the voltage signal is at 50 hertz frequency, that is the standard power frequency in India, when it is getting transferred to the secondary side, the voltage signal should have the same frequency value. that is of 50 hertz. Okay.
Yes, ma'am.
Yes, ma'am.
Next, coming to the different types of the windings available in the transformer, a single phase voltage transformer basically consists of two electrical coils of pair, one called the primary winding and another called the secondary winding. So here for this syllabus, we will define the primary side of a transformer as the side that usually takes power and the secondary as the side that usually delivers power, right? So in a single phase voltage transformer, the primary is usually the side with higher voltage. The two coils are not in electrical contact, as I said just now, with each other, but are instead wrapped together around a common closed magnetic iron circuit, that means iron core, mainly the core is of ferrite core, but the other materials are also used other than iron, the ferrite core, soft magnetic materials, the air medium can also be used as the core. The soft iron core is not solid but made up of individual laminations connected together to help reduce the core losses. Core losses means the losses generated inside the core depending upon the materials used to form the core of the transformer. The two coil windings are electrically isolated from each other but are magnetically linked through the common core, allowing the electrical power to be transferred from one coil to the other, from one primary winding to the other secondary winding. When an electric current passed through the primary winding, a magnetic field is developed, which is called the Faraday's laws of electromagnetic induction, which induces a voltage into the secondary winding depending upon mutual induction. So, what is the overview of this transformer basics? That for a transformer, there is no direct electrical connection between the two coil windings, thereby giving it the name also as the isolation transformer. So, isolation transformer is one type of transformer which is a little bit different from the power transformer or distribution transformer, but it isolates the two electrical circuits. That's why we can give a suitable name as isolation transformer, which is the alternating name of transformer as well. So generally the primary winding of transformer is connected to the input voltage supply and converts or transforms the electrical power into the magnetic field, and the job of the secondary winding is to convert this alternating magnetic field into electrical power, producing the required output voltage. So this is all about the basics of transformer and the working principle of transformer. Now transformer can be of many types. Depending upon the many factors, transformer can be categorized in many ways, but the mostly used transformer is a power transformer, where the voltage level is high compared to the other types of transformer. So what is a power transformer? First we'll see the definition of power transformer. It's one type of transformer that is used to transmit electrical energy in any component of the electronic or electrical circuit between the distribution primary circuits and the generator. These transformers are utilized in distribution networks to interface step-down and step-up voltages. The usual form of power transformer is fluid immersed, and the life cycle of these instruments is approximately 30 years, right? So that means these power transformers mainly are a fluid immersed type of transformers, because dry type of transformers are also available. So this fluid is basically used as the cooling medium, right? So the life cycle is high compared to the dry type of transformer. So mainly the power transformer is fluid immersed transformer and can be divided into three basic types of transformers depending upon the voltage ranges. They are large power transformer. So the large power transformers can be from 100 MVA and beyond. And next is the medium power transformers. The range of medium power transformers can be from 100 MVA. And the third one is the low power transformer. Small power transformers can be from 500 to 7500 kVA. These transformers transmit the voltage. It keeps a low voltage, a high current circuit. Definitely, voltage level is low, current will be more because the product of voltage and current, which is power, should be remain same throughout the operation. So a power transformer works based on the principle of Faraday's induction law. It explains the power network into areas where every gear attached to the system is designed for the rates set by the power transformer. And next one is distribution transformer. These transformers are mainly used for the distribution of electricity to the household or commercial uses. They step down the high line voltages larger than 11 kV into the standard domestic voltages of 120 or 240 volts. Now this slide is showing different types of transformer. The main three types of transformers are the power transformer, distribution transformer, and measurement type transformers. Okay, you can see that power transformer can be of again two types: the step down transformer and step up transformer. In case of step down transformer, you can see the voltage level is getting reduced from the input voltage, right? And also uh, here, the secondary circuit is having lesser number of turns as compared to the primary number of turns. Whereas in case of step up transformer, see the secondary side voltage is getting step up compared to the primary side voltage. And here the number of turn is higher at the secondary side compared to the primary side. Okay, so you will understand this thing a little bit more when you will study the equation of transformer, right? But for the time being, you just learn that depending upon the number of turns, the level of voltage can be increased or decreased at the output side or at the secondary side of the transformer. Now, these are different types of a transformer based on the material used at the core. It can be of air core transformer and ferromagnetic or iron core transformer. In air core transformer, definitely the uh, core is made of either any plastic or it's simply air. In ferromagnetic or iron core transformer, definitely the core is made of iron or any ferromagnetic material. So losses are less in air core type of transformer, and widely used transformers in electrical applications is the ferromagnetic or iron core based transformer, and air core transformer is mainly used in electronic applications in electronic circuits, mainly at radio frequency range. Depending upon the voltage level, it can be of two types: step up transformer, step down or down transformer. Right, in step down transformer, definitely the output voltage level will be increased compared to the input voltage level. In step down transformer, the reverse is true. That means secondary side voltage level will be less compared to the primary side or input voltage level. Depending upon the application or range of used voltage, it can be of two types again: power transformer and distribution transformer. Right, the power transformer carries very high voltage levels, and distribution transformer is widely used in different applications in our homes or in different domestic appliances where the voltage level is low, just 120 or 240 volt. Next is isolation transformer. So this isolation transformer is also widely used in different electronic circuit applications, which is slightly different from the power or distribution transformer. Because here, in case of isolation transformer, mainly the two windings, the primary and secondary windings, carry the same number of turns, right? So they are mainly, the isolation transformers are mainly 1:1 transformer, right? Voltage level will remain same. So their use are a little bit different. That's why they are widely used in different electronics applications, like in power electronic circuit, we use isolation transformer. Next is instrument transformers. Instrument transformers are also widely used transformers. They work on Faraday's laws of electromagnetic induction, and these transformers can be of again two types: CT, the current transformer, and PT, the potential transformers. You may heard of this term instrument transformer, CTPTs, etc., because already you have studied electrical installations in module 6, which uh, includes the applications of different switchgear instruments. So instrument transformer is one of them. Can be used in the switchgear because they can be used as the measurement device and the protective device as well. Right? So CTs, PTs are used in power system applications to protect different other switchgear components like relays, circuit breakers, etc. So they are mainly used as protective devices. They can be also used for the protection purposes of transformers, bus bars, generators used in different switchgear applications, and also they can be used as measuring instruments. CTs, PTs, the current transformer, potential transformers, though they are transformers, though they are based on primary winding, secondary winding, and simply the Faraday's laws of electromagnetic induction, but still they can be used for the measurement purposes as well. For the measurement of current, main current or the supply current transformers can be used for the measurement of supply voltage in high voltage power system transmission line. Potential transformers, which are nothing like the power transformers, are used widely. Next is auto transformer. Auto transformer is in one another type of transformer in which primary windings, secondary windings, core material, everything is as similar to the that of the power transformer or distribution transformer. But here, what happens? What is the difference here? Actually, in auto transformer, the primary winding and secondary windings are closely wound around each other, around the same core. Okay, so here above the primary winding, around the core, the secondary winding is wrapped, and the part of secondary winding is taken as the output, or a part of the secondary winding is connected with the load side. So when I'll explain the principle of auto transformer, both single phase and three phase, then I will show you the circuit diagram later on, after the completion of basic single phase and three phase transformers as per the curriculum. So there we will be able to understand that how auto transformer works. But for the timing, you just understand that auto transformer is just like a transformer. It also works on the principle of Faraday's laws of electromagnetic induction. Next is based on the cooling medium. Transformer can be of two types: the dry type transformer and the oil immersed transformer. Right? So oil immersed transformer are more advantageous compared to the dry type transformers. The lifespan of dry type transformers are less compared to the oil immerse transformer, right? Because here in case of dry type transformer, mainly the air is used as the cooling medium. Okay, next is the single phase transformer, three-phase transformer. That means based on the type of supply, but the transformer can be of two types, the single phase transformer and a three-phase transformer. Definitely if supply line is of single phase transformer is used, and if three-phase supply lines are available, then we can connect a three-phase transformer with that three-phase supply lines. And lastly, depending upon the type of the core, it can be of again two types, the core type transformer and the shell type transformer. So based on the applications, the type will be chosen, but core type transformers are widely used transformers in many applications. So this is all about different types of transformers. Okay. Next we'll move on to the ideal transformer. This ideal transformer is slightly different from the actual transformer, because in ideal transformer action, uh, there is no losses, and practically no transformers are free of losses. So definitely the practical transformers or non-ideal transformers are totally different from the ideal transformer action. So look at the block diagram of the ideal transformer. Uh, it includes the primary winding having NP number of turns, which is connected to the input voltage, which is of alternating type PT, generating an alternating current IP, and it includes also the secondary winding having NS number of turns, and the secondary side is connected to a load, an AC load. When it is connected across the secondary current, secondary current will start flowing through the load circuit, which is IS, right? And both these windings are wrapped around the common core, which involves the common magnetic flux depending upon the Faraday's laws of electromagnetic induction. So this common flux is phi m flowing through the core. It is confined within the core. And what is this E dash P? E dash P is nothing but a primary induced EMF across the primary side. And what is ES dashed? ES dashed is the secondary induced EMF across the secondary coil, right? So EP dashed will be developed because of the flux, because of the Faraday's law or the Lenge's law. EP equals to N d phi dt, NP d phi dt, right? And this phi is the magnetic flux will be generated from the alternating voltage Vt or alternating current Ip. And depending upon this EP dashed or this mutual flux phi m linked with the secondary coil, the secondary EMF ES dashed will be also developed, which is nothing but proportional to ns d phi dt. So this phi is common for the generation of this both voltages, both induced EMFs at primary and secondary side respectively, right? So flux produced by one coil is linked with the other coil to induce the voltage, and these coils are stationary. Coils are static. Coils are not moving. They are not rotating, right? So only the flux is time varying. Flux is alternating. Time varying means alternating, right? Why it's alternating? Because it is produced due to the alternating current flow, whenever this alternating voltage AC voltage is connected with the primary current, this primary side, the alternating current IP will be flowing to the primary winding. So this current is alternating type IP, and the flux phi is generated because of this alternating current. So this phi is also alternating in nature. So it's a time varying flux. So though the coils are stationary in nature, but because the flux, the common flux which is confined within the core is of alternating type, alternating EMFs will be induced at both sides of the transformer. Is it clear to everyone? You can see
Yes.
flux is only flowing through the core, so it will be linked with the primary coil as well as it is linked with the secondary coil, and definitely there will be some leakage flux which will neither link with the primary or not the secondary coil. So that leakage flux will create some noise, some errors in the transformer working. Definitely that will cause some losses. So based on the Lenge's law, E1, that is the induced voltage at the primary side, is just minus N1 d phi dt, d phi m dt. Phi m is the common flux, the mutual flux, and N1 is the number of turns in the primary winding. And the negative sign indicates, as per Lenge's law, that the effect is opposing the cause. That means the EMFs which is generated at the primary side will oppose the very cause of it, which is nothing but the supply voltage. Okay. And E2 is the voltage EMF developed at the secondary side, which is equal to minus N to d phi m d2. This phi m is again the mutual flux, and N2 is the number of turns at the secondary side, and its minus sign will be indicating that the EMF generated at the secondary side will oppose the very cause of it. So if the source voltage is sinusoidal in nature, right? Like V is Vt, the input voltage as Vm sine omega t, right? The flux generated will be also phi m sine omega t, right? Flux is produced because of the alternating voltage. So if V is Vm sine omega t, flux is also phi m sine omega t. And EMF induced at the primary side EP dash is proportional to ddt of phi m. So n times ddt of phi m. So considering phi equals to phi m sine omega t, what you are getting as EP? EP is ddt of phi max. Phi is phi max sine omega t. So ddt of sine omega t means
Omega cos omega t.
yes, and omega is 2 pi f, right? Omega is angular frequency in rad per second, so omega is 2 pi f. So simplifying this, you will get EP dash is equal to 4.44 NPF into phi max, whereas ES dashed is equals to 4.44 into NS times F into phi max. So EP dashed by ES dashed is just equal to NP by NS. This is the basic voltage relationship for ideal transformer. That means EP-NS is equals to ES-NP. EP dashed NS is equals to NP ES dashed, right? Where EP dashed is the voltage induced in the primary in volt, ES dashed is voltage induced in the secondary in volt, NP is number of turns in the primary coil, NS is number of turns in the secondary coil. So this is also called as turns ratio. NP by NS is also called as turns ratio. The voltage ratio P dashed by ES dashed is called as turns ratio, right? That means if NP is higher than NS, If NP is higher than NS, what is the relationship between EP dash and ES dash? Can anyone tell me? EP dashed by ES dashed is NP by NS. Now, if NP is higher than NS, NP is higher than the NS.
Step down.
Why? Why step down? Because EP will be higher. If NP becomes higher following this voltage relationship, what will happen? EP dashed will become more. That means ES dashed will become less compared to EP dashed. So definitely EP dashed will be larger than ES dashed, representing that secondary voltage is less. That means it's a
Step down.
transformer, right? So if you have any question up to this, you can raise your hand because today's class is going to get over, so I need to stop here. So if you have any questions, you can raise your hand. Otherwise, I will stop here.
Hello, ma'am.
Yes, Renita.
Ma'am, can you take my attendance now? I have to leave.
Yes, I'm taking your attendance.
Okay.
Okay, you
Roll.
want to leave now? You want to leave now?
Yes, ma'am. I'm in hospital currently. That's why.
Okay. Your roll number is 50.
50. Yes.
Oh, okay, Renita, you may leave.
Thank you.
Okay. Others, please wait. I'll be taking your attendance. Let me mark Renita present first. Okay, roll number 1,
Present, ma'am.
2,
Present, ma'am.
3,
Present, ma'am.
4, Lisan, 5,
Present, ma'am.
6,
Present, ma'am.
7,
Present, ma'am.
8, 9,
Present, ma'am.
10,
Present, ma'am.
11,
Present, ma'am.
12,
Present, ma'am.
13,
Present, ma'am.
14,
Present, ma'am.
15,
Present, ma'am.
16,
Yes, ma'am.
17,
Yes, ma'am.
18,
Present, please, ma'am.
19,
Present, ma'am.
20, Moli, 21, 22,
Yes, ma'am.
23, 23 is absent. 22, are you there? 22?
Yes, ma'am.
Okay.
Yes, ma'am.
And Anushrita is also present, right? Anushrita? Okay, Anushrita is absent. Next, 25,
Present, ma'am.
26.
Present, ma'am.
Did I call
Ma'am,
you?
you
Shagnik?
forgot to take 24.
Yes, yes, Shagnik. Okay, thank you. Next, 26, Onindo.
Yes, ma'am, present.
27, Aman. 28,
Present, ma'am.
29, Harsh.
Hello,
Harsh, are you there? Harsh, yes. Who is this?
ma'am.
Yes.
21. Ma'am, Anushrita De.
Okay. What happened to you, Anushrita?
Ma'am, actually, I don't know, ma'am. The net got suddenly disconnected and I had to connect back.
Okay.
Ma'am, I'm using BSNL, so maybe that's why.
Okay.
Ma'am, her phone is broken down. He will purchase today.
Harsh, phone is broken down. Yes. Who is this?
Hello, ma'am.
Yes.
Am I audible?
Yes, Anushrita, you are absolutely audible.
Yes, ma'am.
Yes, Prince, what happened to...
Ma'am, Harsh's phone is broken down yesterday, so he's not able to join the class today.
Yes.
He will purchase the new phone today.
Okay, okay. No problem. Next, Shangita, 30. Shangita, are you there? 31. Shantanu? 32.
Present, ma'am.
33.
Present, ma'am.
34.
Present, ma'am.
35.
Yes, ma'am.
36.
Present, ma'am.
37.
Present, ma'am.
38.
Present, ma'am.
39.
Present, ma'am.
40. 40. 41. 42.
Present, ma'am. 41 present.
41 is present. Okay. 42
Yes, ma'am.
is also present. 43.
Present, ma'am.
44.
Present, ma'am.
45.
Present, ma'am.
46. 47.
Present, ma'am.
48.
Present, ma'am.